Magandang araw mga kasipnayan! Welcome to Sir Ocnic's YouTube channel. In this video, we will find the permutation of objects arranged in a circle. But first, let us have a review on distinguishable permutations. Find the number of distinguishable permutations in the word BAYANIHAN. Since BAYANIHAN has 9 letters, N is equal to 9. A has 3, N has 2, and applying the concept of distinguishable permutations, that will be equal to 9 factorial all over 3 factorial times 2 factorial. Expanding the numerator, we will arrive at 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. All over 3 factorial all over times 2 factorial. Cancelling the common factor between the numerator and the denominator, and by simplifying the remaining operations on both numerator and denominator, we will arrive at 60,480 all over 2, which is equal to 30,240. Find the number of different ways of placing 5 red marbles, 4 green marbles, and 2 blue marbles in a row. Since we have a total of 11 marbles, our n is equal to 11. And by applying the concept of distinguishable permutations, we will have 11 factorial all over 5 factorial times 4 factorial times 2 factorial. Expanding the numerator, we will have 11 times 10 times 9 times 8 times 7 times 6 times 5 factorial all over 5 factorial, 4 factorial, 2 factorial. Cancelling the common factor, which is 5 factorial, and by simplifying the remaining operations on both numerator and denominator, we will arrive at 332,640 all over 48, which is equal to 6,930. Let us now discuss cyclic permutation. A cyclic permutation is a permutation which shifts all elements of a set by a fixed offset, with the elements shifted off the end inserted back at the beginning. If n objects are arranged around the circle, the number of permutation of n different things is quantity n minus 1 factorial. But if n objects are arranged around a keyring and the like, the permutation is given by the formula quantity n minus 1 factorial all over 2. In how many ways can 5 people be seated at a round table? Using the formula quantity n minus 1 factorial with n is equal to 5, we have 5 minus 1 factorial, which is equal to 4 factorial. And 4 factorial is equal to 24. That means we have 24 ways in arranging 5 people at a round table. A spinner is divided into 6 equal parts. How many ways can you arrange 6 colors in it? Using n minus 1 factorial with n is equal to 6, that is equal to 6 minus 1 factorial or 5 factorial. And 5 factorial is equal to 120. In how many ways can 7 children be seated at a round table if they can sit anywhere? Using n minus 1 factorial with n is equal to 7, that is equal to 7 minus 1 factorial or simply 6 factorial. And 6 factorial is equal to 720. In how many ways can 7 children be seated at a round table if the eldest will be seated at the right side of the youngest? In this case, the eldest is seated at the right side of the youngest. Therefore, we must treat the two persons as one. So, using n minus 1 factorial, our n here is equal to 6. Again, simply because the youngest and the eldest will be treated as 1. So, that is 6 minus 1 factorial, which is equal to 5 factorial. And 5 factorial is equal to 120. Therefore, we have 120 ways. In how many ways can 7 children be seated at a round table if the eldest and the youngest will be seated side by side? In this problem, the eldest and youngest is seated side by side. They will be treated as one, but their positions can be interchanged. So using n minus 1 factorial, we will have 2 factorial times the quantity 6 minus 1 factorial. Again, it is 6 because the eldest and the youngest is treated as 1. And we need to multiply by 2 factorial simply because the positions of the eldest and the youngest can be interchanged. So this one is the same as 2 factorial times 5 factorial. 2 factorial is 2 and 5 factorial is equal to 5 times 4, 20 times 3, 6 times 2, 120. So 120 times 2 is equal to 240. In how many ways can 7 different colored beads can be arranged on a bracelet? In this problem, we are going to use n minus 1 factorial all over 2. As mentioned a while ago, this formula will be used if objects are arranged in a keyring or the like. So we will have n is equal to 7. That means we have 7 minus 1 factorial all over 2, which is equal to 6 factorial over 2. 6 factorial is equal to 720 divided by 2, that is equal to 360. In how many ways can 8 keys be arranged in a keyring? We will use again the formula n minus 1 factorial all over 2 because of the keyword keyring. Our n here is equal to 8. Therefore, we will have 8 minus 1 factorial all over 2, which is equal to 7 factorial all over 2. And 7 factorial is equivalent to 5040 divided by 2, that is equal to 2520. In how many ways can 6 people be seated at a round table if 2 particular students must not be seated next to each other? To solve this one, let us solve first for the total number of ways if there are no restrictions. So using n minus 1 factorial, we will have 6 minus 1 factorial, which is equal to 5 factorial or simply 120. The next thing to do is let us solve for the total number of ways if they are seated next to each other. So since they are seated next to each other, the two students are treated as one. Therefore, we will have n minus 1 factorial. Our n now will be equal to 5, simply because, again, the two students are treated as 1. And multiply 5 minus 1 factorial by 2 factorial because the positions of the two students can be interchanged. So that is 2 factorial times 5 minus 1 factorial or simply 2 factorial times 4 factorial, which is equal to 48. The next thing to do is to subtract the number of times they are seated next to each other from the total number of ways the group can be arranged. Since we are asked on the number of ways can 6 people be seated if two particular students must not be seated next to each other. So that would be 120 minus 48, and that is equal to 72. Let us now summarize what we have discussed in this video. If n objects are arranged around a circle, the number of permutation of n different things is quantity n minus 1 factorial. If n objects are arranged around the keyring and the like, you are going to use quantity n minus 1 factorial all over 2. Let us now check your knowledge. Try to solve the following items. Do not forget to pause the video while answering the activity. In how many ways may the vertices of a regular pentagon can be named using the letters P, Q, R, S, and T? Using the formula n minus 1 factorial, we will have n equals 5 because a pentagon has 5 vertices. So that will be 5 minus 1 factorial or simply 4 factorial. And 4 factorial is equal to 24. In how many ways can 10 different colored beads be arranged on a bracelet? We will use n minus 1 factorial all over 2. N here is equal to 10. Therefore, we will have 10 minus 1 factorial all over 2, which is equal to 9 factorial all over 2. 9 factorial is equal to 362,880 divided by 2. That is equal to 181,440. In how many ways can the dwarves of Snow White can be arranged in a round table if Doc and Sleepy must be seated next to each other? Snow White has 7 dwarves, but in this scenario, Doc and Sleepy must be seated next to each other. Therefore, Doc and Sleepy will be treated as one. So in this case, our n is equal to 6. Since Doc and Sleepy can be interchanged, we are going to multiply 6 minus 1 factorial to 2 factorial. So that is equal to 2 factorial times 5 factorial, or simply 240. Thank you for watching Sir Ocnic's YouTube channel. If you think that this video is a big help, hit like, feel free to share, and do not forget to subscribe. Always have fun in learning math. Enjoy learning! Thank you and God bless.